Okay, good morning. So, I want to continue this important lesson, this on differentiation rules. So if you remember, we talked about categorizing our functions so that we do them once, differentiate them once, and put them in a table, either memorize them or use them later if we need to, okay? So far our table is actually very sparse. We just have only 2 items there. So do you remember what are those items? What are those items that we have? We have the constant function, yes. Let me just do it here. We have very a simple table so far. We have our function here and its derivative here. We learned that the constant function, its derivative, so let me just write it with the lowercase letter c. The derivative is 0, and we didn't completely prove it mathematically, but we were able to see some of the examples of this power function, and we were more or less convinced that the rule for all these functions is the same. So you will bring the exponent down and then subtract 1 from the exponent, and I mentioned that it is extremely important to realize that c should be a constant, yes? So c should be your constant, then you can calculate this. And I added actually something here. I told you that these 2 are in the formula sheet, but I want you to immediately understand, so let me write them by red here below them, okay? So if I have x, where c is equal to 1, c goes down, c minus 1 is 0, x to the power 0 is 1, so the derivative becomes simply 1. And I calculated, if you remember, the derivative of the square root of x. I told you that even though this is not demanded from your side to memorize it, I really want you to memorize it. Otherwise, you have to change this to exponent form, use this formula, simplify it again. It is possible, but I would recommend you to try to memorize it. And then there is another one I also added in this list, 1 over x. You can calculate that this becomes 1 over x squared. So none of these red ones are in the formula sheet because you can get all of them from one single formula, and that is the formula there. But there is one more part left here, so the lesson today will not be very long, but it's very important. So if I ask you, now you have that formula. Do you remember we solved some problems using this formula? If you don't mind, let me just remind you a little bit. So for example, if I give you this function f of x and ask you to calculate the derivative, so let me write it as 1, for example, over the 3rd root of x squared. If I ask you to differentiate this function, just for refreshing your memory, what I'm supposed to do first, I cannot start differentiation process immediately because what you see here is not exactly in my table. I can only do that if I can write it in exact form so that it is exactly one of those functions that I have in my table. So then what should I do here? So I change my color, so showing that this is the solution. So this blue part is the solution. So first of all, you write it as what? X to the power of 2/3. But this is still not in that form. You realize that you bring it up and make it negative. Yes? And then you differentiate. Because now this is, if you compare this one with that one, c is equal to minus 2 over 3. So I can start differentiation process immediately right now. So I would say that the derivative of f minus 2/3 goes down, and then I will have x to the power of minus 2/3 minus 1. Okay, so you calculate this patiently. So this becomes minus 2/3. Minus 2/3 minus 1. What is the answer? Minus 5, yes. So minus 5/3. You can stop here, so this is why I changed my color. Up to here is mandatory, but I would recommend you to learn this simplification part as well. So what you do, I would write it minus 2 over 3 and I will bring it back, it becomes positive 5/3. I will not stop there. I will continue to write it as third sum, using the third sign. Yes, so it becomes -2/3, and then I will write it the third root of x to the power of 5. But even we can simplify it more. Yes, why? Because the third root of x to the power of 5 can be written as the third root of x to the power of 3 multiplied by the third root of x to the power of 2. But then this one is just simply x. That one becomes the third root of x to the power of 2. So this is why I prefer, instead of writing this, to write -2/3x third root of x squared. So the ones in blue are mandatory, but the ones in green, optional for the time being, but I really recommend you to be able to do these calculations easily. Now the question is, I want to ask you a very simple question. If I ask you, do you know how to differentiate this function? You would say yes. The derivative is 2x. If I ask you, do you know what is the derivative of this function? You will say yes. But now I am allowed to combine them by adding them, and if I ask you what is the derivative of this function, then we want to just explore this one. So if these rules, if we don't know what is this addition rule and what is this subtraction rule, the sum rule and the difference rule, then it means that even though I can calculate this, the derivative of this and the derivative of this, there is no reason that I believe that the derivative of the sum is the sum of the derivatives or something like that. So we want to prove that that is indeed the case, and we are lucky. We don't need to be worried about these things. So there are some rules that I want to write here. I will call them general rules, yes? So let me title them General Rules. By general rules, I mean that these rules apply for any kind of functions, not the functions just in your table. So this is this. I will write this, and then I will try to prove them for you to convince you that they are indeed the case. So if I give you a function, number one, if I give you a function f, and I multiply it by a constant c, and then I ask you to differentiate the new function. For example, I give you x to the power of 5. If I ask you what is the derivative, you immediately answer 5x to the 4. But now I multiply it by 3 and I ask you the same question. I ask you what is the derivative of this new function. The point is that we are lucky, and this c doesn't play any roles actually, not that big. So it means that you just differentiate your function assuming that c is not there, and when you found the answer you just multiply it by c. Of course this is not trivial. I want to show that this is indeed the case, but for the time being let us write the rules here. Number two is, if I give you this function, you know how to differentiate. If I give you this function, you know how to differentiate. Now the nice rule is that if I add them and I ask you what is the derivative of the whole expression, the answer is simple. It's the sum of the derivatives. So it means that if I give you two functions and I add them and I ask you to differentiate the total sum, you don't need to be worried. You differentiate the first part, you differentiate the second part, and add the derivatives. One other way to read this, which I would say is important, is this. It doesn't matter if you add first and then differentiate, or you differentiate first and then add. The results are the same. It's not trivial, we will prove it, but I want you to understand what is the meaning. So it doesn't matter if I add first and then differentiate, or differentiate first and then add the results. The answer is the same. And the same thing is happening for the difference. That is also very nice and simple. So if I have the difference of two functions and I want to differentiate the difference, it becomes the derivative of the first one minus the derivative of the second. Yes? Okay, but let me write number 4, which will be a topic in Math 4. So you might think, so let me write it with red. You might think that I have something similar for the product. Yes? So if I multiply two functions and I ask you to differentiate it, you might think, because of the impression you get from these two, you might think that, okay, I multiply and differentiate. Second, it doesn't matter, I can differentiate first and then multiply. But this is wrong. I want you to write it and cross it over. This you have to wait, according to the system, until Math 4 to understand what is the correct rule, okay? And the same scenario doesn't work for the quotient, for dividing two. If you divide two functions and if you want to take the derivative, it is not possible to differentiate the numerator and denominator separately. So please write them and cross them over.
Can you give us a hint of what it is then?
No, the formulas are, if you want, I can write the formula. The correct formula for the product is the derivative of the first one multiplied by the second one itself, plus the first one multiplied by the derivative of the second one. And if you want the correct form for this one, this becomes the derivative of the numerator multiplied by the denominator minus the numerator multiplied by the derivative of the denominator divided by denominator to power 2. So this is called the product rule.
Well, but that's obvious. Come on.
Yeah. Pretty much.
Yes.
Yeah.
And that is called the quotient rule. But we don't study them. So this is the topic in Math 4.
Yes.
But be sure that you understand these formulas are not correct. Okay? And then let me write this. This is the sum rule. The difference rule, yes. Actually, this is also a product rule, but a very specific one. So this is why I don't give it a name. Okay? So you don't need to know about these things. And these are not given in the formula sheet. So be careful. So these general rules are not there. You will get that table without the red parts. Okay? Now let us try to convince ourselves. I will prove these two for you today, and I will leave this one as an exercise because that's very simple. Yes?
Wait, were the first, second, and third general rules not part of the formula sheet?
No.
Okay.
No, they are not.
Are they really useful for the test?
Yes, of course, because otherwise I should always give you very simple functions, but I can give you simple polynomial functions that you can use them. Definitely, they are sure. You see that they are in the book. But this, for some reason, they have decided to postpone it to Math 4. Okay, so let us now understand why the first formula is correct. Okay, so how should I prove that? I would say that I have a function, you multiply it by a constant, it becomes a new function. Yes? I want to calculate the derivative of my new function. Yes? Of course, according to this, the answer to the question mark is on the board. It is c times the derivative of f, but we want to prove this, that this is indeed the case. So how should we do that? There is only one way to find the derivative if you don't have any formulas, and that is the definition of the derivatives. My goal is to answer that question mark. I would write the derivative of g as the formula. There is one single formula. If I want to know something new about derivative, there is only one way. You have to use the definition, nothing else. So then, do you remember what was the formula? I want to see how many of you respect the soul of Leibniz or Newton. So what is the derivative formula for g?
Gx plus
H, the limit g of x plus h minus
G of
g of x, and then
over h.
over h goes to
Zero.
0. Yes. Okay, now can you help me to complete this for this problem in hand? Yes, so I would say the copy-paste parts are these two. Okay, g of x is clear. It's minus cf of x. But I want you to help me to write something for g of x plus h. What can I write if I want to?
Cx plus ch.
No. C times, because you see, how do you interpret this? You send an input into the, so what do you see? If you want to draw a diagram for this, this is your g function, and then you are sending x here. So if you send x here, this function sends it the input to another function, and then multiply the outcome by c. So it is not independent of f. So you see, it will take your input and put it in another function, and then what is the result? It is multiplied by c. Now I am sending x plus h in. So what can I write here? It becomes c times f of x plus h. Yes? So that is the. And then it is clear that I can factor c out. Yes, so I can factor c out, c limit f of x plus h minus f of x over h goes to 0. Because c is in common, I can factor it out. You can factor it out here, and then of course that's a constant, I pull it out. But now if I ask you what do you see on the board, this is the definition of what? The derivative, but the derivative of which function? F. And there is a c behind that. So it becomes c times
Derivative
of f.
Yeah.
So the question mark is now clear. It is c times f prime of x. So that is the proof for the first one. The proof of the second one has the same idea, but it's a little bit more involved. Let us just do that together. For the second one, because I have two letters involved, f and g, so I don't want to use letter g because letter g is reserved for the second function, and I don't want to use h because h, I don't know, in your book they are using h here and there. It's confusing and it's not very good. So I will change the letter of my function. I would say that let, I don't know, you can call it u of x, to be f of x plus g of x. And then my question is that, what is the derivative of this function? Is that clear? I have the sum of two functions. I call it a new function u of x. My goal is to show that the derivative of u follows this rule. It becomes the derivative of the first one plus the derivative of the second one. But that is also easy. You can help me to do that. I want to answer a question mark regarding the derivative. There is one way for me to do it if I don't have it in my table. So there is only one way. What is that one way? Using the definition. Okay, and then hopefully everyone agrees that this is the correct definition for the derivative of the new function u. Yes?
Yes.
Understandable?
But you don't have an f of x where, like, shouldn't it be involved in
Yes.
some way or another?
You need to be patient, then it becomes involved.
All right.
If you are not patient, it is not involved.
Yes.
Yes. Okay, so now we have to continue. Okay, at the copy-paste parts, as usual, I just put them here. What is u of x? It is written on the board. It is this one, but if I write it in this way, it is wrong. What is wrong with this?
You have to put it in parentheses.
Yes, exactly.
Yeah.
And now I want you to help me to write something for u of x plus h. What should I write? Yes?
This might be very long, but you can do it for each of them, like
No,
f of
that's
x.
the only way. Yeah.
Is it? All right.
Yeah. So it becomes, so you see this function, when you send input x in it,
Yeah.
it will take that input, gives it to two functions f and g, calculate them, add them. Yes, that's the role of the function. So it will do the same thing if I send x plus h in. So this becomes f of x plus h plus g
of x.
of x plus h. Yeah, that's inevitable. That is the only way we can do that. Understandable for everyone?
Yeah.
But now you have some idea, at least I have given you the formula. So you see that I should be able to connect the derivative of u to the derivatives of f and g in some way. And I think it's not very hard to guess what to do. Can you tell me what to do now? I want to do it in a way that the derivative of f appears in my calculations and the derivative of g also appears in my calculations in some way. So then what is the motivation? This is the motivation to do what? Anyone else? Yes?
You separate them into their two definitions and add them.
Okay, so that's, yeah. So what he's telling you is actually this one.
Like, so you have g
Yes,
prime.
it is minus f of x because I
Exactly.
multiply minus sign in. It becomes minus g of x.
So that's their.
And I have one number, second number,
Yeah.
third, and fourth. I can combine them in a way that I want to, yes? And then I combine them in a way which is efficient for me. I would write f of x plus h. I write minus f of x next to this one.
Yeah.
And then I have g of x plus h, yes? And then I have minus g of x, agree? Divided by h goes to 0. Okay? So now I have one expression and another expression dividing by h. I can divide this by h and this by h separately. Yes? So what happens here?
They become two definitions. Oh.
Yes, so it becomes two definitions, exactly. So it becomes f of x plus h minus f of x
Divided by
h
Plus.
plus g of x plus h minus g of x divided by h, and then I have h going to 0. Yes? And now h goes to 0. What is the limit of the first part only? It's exactly the formula for the derivative but for function f. And that limit of the second one is the derivative definition but for function g. So then it becomes f prime of x plus g prime of x. Yes? Okay, now I changed my mind. I want to do number 3 again for you. The reason is that the method that I want to use is different from these two methods. Now I have two formulas. I want to combine these two formulas to prove the third one without having to go through all these processes. Okay, so I want you to learn this. Of course, if you don't want to, I would still recommend you to prove this one using the definition method. But I want you to teach a different way. That's also good to learn. Okay? So from now on, you send this one to your memory. If I add, differentiate second, I can differentiate first and then add. If I multiply by a constant, be careful, let me write this. Here c is a constant. I'm using this little c for constant value. So c is a constant. So this, I underline it, okay? So if I multiply my function by a constant and then differentiate the whole function, I don't need to be worried about the constant. I just differentiate the function. Whatever the answer is, I multiply it by that constant. Yes? Okay, now I want to prove this, the third one, using this one and that one, because I have already proven this one for you, so I can use them now if I want to get some new information. Okay, so what should I do? Yes, that's good. So I can write it here. So here, number 3. So I will start from the left-hand side, which is equal to f minus g prime. Can you see what is the trick I'm going to do? I want to use these two rules that I'm sure they are true because I proved them. I want to use these rules so that I can show the third one without having to go through all these long processes. How can I do that? This is always important. Difference and addition, the subtraction and addition operations are all more or less the same. You can say that a number a minus another number, you can interpret it as a difference, or you can interpret it as a sum, but sum with the negative of that number. Yes? So any difference can also be interpreted as a sum, but the sum with the negative value. And the negative value, you can still interpret it as -1 times b. That's
So
the idea.
The constant is -1.
-1.
Okay.
So here, what we do, we write f plus -1 g. I want to differentiate. According to the sum rule, I have two functions involved. I want to differentiate it. I differentiate the first one, plus I differentiate the second one.
Times 1.
But for the second one, I use this rule, yes? So I will copy and paste the first part, plus, what is the answer to this one? This rule number 1 tells me don't bother about the constant -1, just differentiate your function, whatever it is, multiplied by -1. But now that the differentiation process is finalized, no one writes it so complicated. People prefer to write it simply as -g prime. And then if you see this one and that one, you are done. So this means that the left hand side is equal to the right hand side. But I recommend you try to prove the same formula, but using the definition of the derivative. That's a good exercise. Okay, now this will give you a lot of opportunities to differentiate very even hard functions that if you want to use the definition of the derivative, it is sometimes impossible or very, very lengthy. And this example that I want to write is extremely important, both for your future and for the exam. Okay, so this is the only one that I want to teach. I don't know how long it will take, but this is extremely important example today. Okay. So this is the good form of having two whiteboards, yes? So example. So let me write, very important, yes? So I simply write differentiate. Okay, so number 1. So let me write all of them with one color. So number 1, f of x. Let me make it, for example, simple here. So f of x. I give you a polynomial. 5x to the power of 3 plus 4x squared minus 3x plus square root of 2. So we want to differentiate this function now. I will solve it with a lot of details, but I don't want you to write the details in the exam if you don't want to, but I want you to think all the details in your head. If you don't want to write it, no problems. So if I ask you to differentiate this function, so it means that I am asking you to differentiate this function. But this is the sum and difference of 1, 2, 3, and 4 functions. So you need to think in this way. I really don't want you to write all the details. It becomes very lengthy and it is not necessary at all. But I want you to think quickly in this way. You should think that I have the sum and the difference of 4 functions. I want to differentiate according to the sum and the difference rule. I can do them separately. I can write the derivative of the first bit plus the derivative of the second term. Here is minus the derivative of the third term plus the derivative of the last term. But here I need to use rule number 1. So which rules I am using, let me write them here. General rule. So let me write the general rule number 1, no, number 2 and 3. 2 and 3. Yes? And then here I want to use the general rule number 1.
It's 15x squared.
Yes? So separately, just be patient. So I would write, yes, you can write it in the exam very quickly. But I don't take the derivative of 5 because 5 is a multiplicative constant. Don't worry about that. You only need to be worried about your function. And then the same thing here. And the same thing here. And of course, let me keep it for the future now. So general rules 2 and 3 are used. General rule number 1 is used. But now I have to refer to my table, yes? And what table is? So you have it here. There is only one formula in your table, and that is this one. If I have x to the power, constant power, I should use this rule, yes? So I will do the same thing here. So here I am using the table. So the derivative of x to the power of 3, what is that? Is 3x squared. The derivative of x squared is 2x. The derivative of x is 1. The derivative of a square root of 2 is 0. Because a square root of 2 is a constant. Don't get confused. I have seen students sometimes use this formula for a square root of 2. Yes? This is the square root of x. You cannot write 1 over 2 square root of 2. That is wrong. Square root of 2 is a constant, so I am using this rule here. The constant derivative is 0. Yes? And then this lesson today is finished here, matrices. So this is simplification. So let me write 5 times 3 is 15, x squared plus 8x minus 3. So if I want to write something here, it's simplification. I want you to write, if I give you that in the exam, I expect you just to write the answer for me. Okay? But it doesn't mean that you should have a shortcut in your thinking. No, the way that you think should be exactly through these lines, but very fast, and you don't need to write it down. So if I give you this in the exam, I expect you to immediately write this one. I don't give any points to you according to these rules. I care about the final answer here because that's so simple. Yes? Is that understandable? But this is the way that you need to think, because if you don't learn to think in that way, you will be a very big problem in Math 4. So I want you to learn this way of thinking, even though this is so simple that you can immediately write the answer. Yes? Is that understandable or not? Okay, now let me give you another example here. I want you to immediately give me the answer, okay? So number 2, f of x equals to minus 3x to the power of 7, I don't know, plus 2x to the power of minus 5 minus pi x to the power of 2 plus the third root of 5. Okay, now can you tell me immediately what is the derivative? Yes? I told you, yeah, because a square root of 2 is constant. Yes. So here, any odd number which is constant, the derivative of it is 0. Don't get confused to use this. I have seen students use this for a square root of 2. No. This is a function which depends on x. Square root of 2 is a constant number. Okay, so can you tell me the answer, everyone? So what is the derivative here?
Is it minus 18x to the power of 6?
No, here, what is the answer to this one?
Yeah.
Yes?
At the last one.
The third root of 5, this is pi, number pi, x squared. Yes? Okay, so tell me, what is the first part? Yes?
21x to the power of 6.
Minus.
Minus 21. Minus 21x to power 6. What is the next one?
Minus
Everyone.
Minus 10.
Minus 10x to power?
Minus 4.
No.
Minus 6.
Minus 6. Minus 5.
minus five,
Minus
minus
1.
one.
It's
Minus
minus
six,
6. Yes? What is the next one?
Minus 2p.
Minus 2 pi
X.
x. What is the next one?
0.
0. So that's the answer. So this is easy, but I want you to, if someone asks you, if one of these rules are not there, this is not correct. So I want you to understand the connection between all these rules and this simple calculation. This goes through all of them, okay? Okay, now I will increase the different types of problems that now we can solve, and this is an extremely important problem for you. Just underline that, so make sure that you really understand every detail. So number 3, let me write it here. F of x is equal to x to the power of 2 plus 1 to the power of 2. I want you to differentiate this. So how should I do that? Let us repeat. Is this formula exactly in our table?
No.
No, because we have only 2 lines in our table, yes? One of them is this constant, one of them is this one. Of course, these are also of this type. So this is not exactly in our table. I have to change the form of the function so that it becomes related to these ones. So what should I do?
Well, I'm asking, can't you interpret what's inside the parentheses as...
No.
You can't do
That is unfortunately no, and that is also an important lesson that you will learn in Math 4. That is called the chain rule.
Okay.
Yes, but you cannot do that. You cannot assume that. That's a very good question, by the way. You cannot assume that x squared plus 1, I can call it capital X. Yes, so you cannot, you can write it, of course, f of capital X is equal to x squared, and someone tells you what is capital X, you tell me that this is x squared plus 1. You can also write f of capital X is 2x. That is also correct. But f prime of the little x is not this one. It needs an extra term, which you don't know yet, and we will not discuss about this. So in Math 3C, if I give you this, there is only one way to do that. And what is that? Yes, Abdul? Yes, you have to expand it first. So this is why, if I want to give you this in the exam, I will keep it up to power 2. Because if I give you higher powers, for you, there is only one way. You have to multiply them and then differentiate. Okay? So for the Math 2C level, 3C level, I will keep this one, probably not that much. Even if I give you power 3, that's also okay, because power 3 is also in the formula sheet. Yes? Okay, so the first thing that you have to do, let me change my color. So the one that I write in blue is actually the solution. So the first thing is to expand that. And the expansion is easy. The first one to the 2, 2 times the first one times the second one,
To the power of 2.
and then 1. And now you are ready to differentiate, and do it quickly. What is the answer to the first part?
3x.
Why
4x
3? 4x to the 3, and then
4x.
4x and finish. That's the derivative. Yes? So let me give you another function. Number 4. F of x equals to, for example, I might give you this, x times x plus 1 times x minus 3. I want to differentiate it. Okay. That is also something I have seen students make mistake. They say, okay, the derivative of x is 1, the derivative of this is also 1, the derivative of this one is also 1, so 1 times 1 times 1 is 1. But I told you that this is not right. I have written it in red and crossed it over. So this is the product of 3 functions, but we don't study the product rule here. So you are not allowed to take the derivative of this one, and that one separately and multiply the derivatives. That becomes wrong. Yes? So there is only one way again for you to do it at this level. What is that?
Multiplying.
Multiplying. Yeah, you have to be patient and multiply. So this becomes, for example, I multiply x in first, so it becomes x squared plus x, and then I find the answer multiplied by the third term. So this becomes x cubed minus 3x squared plus x squared minus 3x. I simplify x cubed minus 2x squared minus 3x. Now everything is ready. So what is the derivative? So let me write the derivative here. What is the derivative now?
3x squared
3x squared.
minus 6x
No, minus
minus 6x.
this is 2. And this is 2.
Wait,
Why
I'm
6?
reading mine. 3x squared.
Minus 4x.
Minus 4x.
where did you get 3x squared from?
I multiply this by that.
Okay,
And then this by that. And then I took these two and simplified them like this.
you're right.
Oh,
you're
you
right.
simplified that. I did it one by one.
No, so you are taking the derivative of this one.
Yeah.
I'm taking the derivative of this one.
Yeah. Can't you do a derivative of the first one you did?
Yeah, you
Before
can
the
do, but you
simplification.
have to simplify at the end again.
Yeah.
It doesn't matter.
Yeah.
So is that okay?
Yes.
Okay, so now let me increase the level here. So what happens if I have this scenario? So number 5. What happens if I have the function of this 4? 5x to the power of 3 plus 2x minus 1 divided by 5x. We want to differentiate this function. Again, be careful. If I want to give you a quotient in your exam, I have to make sure that the denominator contains only one term. Because if it contains more than one term in the denominator, then you have to use the quotient rule, which is not part of your lesson. Okay? Of course, you can use the quotient rule for that one as well, but there is a shortcut to it, because you see that the quotient rule is actually a complicated rule. Even if you know it, it is better to avoid it as much as possible. So, you see it's a fraction. You might think that I cannot solve it because I don't know the rule for the division of two expressions, but in this case you can solve it. How?
Simplify.
What then?
Simplify.
So here, what do we exactly mean by simplify? Because that's not simplification. What do you mean by simplify? Because this cannot be, if I give you this in the exam and I ask you simplify it, it's not possible to simplify it more, yes? Unless you are so genius that you can factorize the numerator immediately, which is probably not that easy or even sometimes possible. And even if you factorize it, there is no way to cancel something in the numerator with the denominator. So the simplification word is not correct here. I'm not simplifying. I want to do some trick to this. Yes?
Can we multiply both sides with 5x?
So you can do that,
Yeah.
but both sides will happen. This 5x will be there. And then what? You want to differentiate both sides, yes? So that's also a good trick, but this will not work. I want you to understand why this doesn't work. If you multiply by 5x, this becomes this. And then what you say that the derivative of this is equal to the derivative of this.
Can't you divide by
Derivative
5?
of this doesn't have any problems. It becomes 15x squared plus 2. But the point is that what is this one and that one? That's a product. And we don't know the product rule. If you know the product rule, that is an alternative way to do that. Yes? But this doesn't work because you still don't know the product rule. Yes? 5 is no problem. That's a multiplication by constant. But x times f of x needs the product rule. So this is why I'm not saying it is wrong, but for this level we don't do it in that way. Yes, Aaron?
Can you multiply the right hand side by 5x over 5x?
No, what doesn't, that's not, there's no point.
Alright.
If you multiply that, then what will happen? It becomes 5x over 5x.
Yeah.
F of x on the right hand side will be the same.
Well, Babak, why don't you divide by x after that? You have 5x, a function of x. Why
No,
don't you
5x, I can,
Times.
so the derivative of this you will see in the future.
But
is
you can divide
5
it by x.
f of x plus 5x f prime of x. This is the answer to this.
Can't you divide by x there? And then you get
No,
x
it
to
is
the other side.
so you have to differentiate. Do you know what is the meaning of pair of brackets?
Yes,
It
then
means
it's-
that you have to multiply and then differentiate.
Yes.
You don't know how to multiply and then differentiate. That's the product. The answer would be this. Okay, any other ideas? Any other ideas? So let me put a star here because you had some ideas for the previous one. So please pay attention to this. Okay, so yes?
I'm not sure if it's correct, but if you mean 5x into 5x over minus 1, I will multiply it by the
So that will work. Yeah, that will work. Thank you. Yes. So, but I want to use an alternative for what Hadi is saying is that you can write it as 5x to the power of 3 plus 2x minus 1, and then write it as this one. If this is 5, you can write it 1 over 5. That's no problem. But you can bring x to the numerator. Yes. And then you multiply it here. This becomes like a polynomial. So this method will work. And actually, I'm using the same method, but I prefer to write it in this way. For pedagogical reasons, but that's completely okay. So I will divide this by that, and then I divide the second one by that one, and then I divide the third one by that one. Yes? Here I have addition, here I have subtraction. This is valid, yes? You know probably that. If I have a plus or minus b plus or minus c plus or minus etc. divided by d, you can write it as a over d plus or minus b over d plus or minus c over d plus or minus etc. This is actually the common denominator, yes? You cannot say I don't know this, because if I give you these two fractions and I ask them to add, because the denominators are the same, you write this. But this is equality. Sometimes you need to go from the right to the left, sometimes you need to go from the left to the right, as in this case. So that's valid, yes? But that's exactly what you said. That's the same thing. So then 5 and 5 are cancelled. x3 and x are cancelled, so x2 is left for you. Here what will happen? X and x are cancelled. What is left for me is 2, 5. Here I have to use the trick that actually Hadiya introduced. There is no way out of it. So I have to write minus 1 over 5, and I have to bring x up. So it becomes x negative 1. Because the only functions that I can deal with are the functions whose base is x and the power is actually a constant. So now everything is in order, I can differentiate, yes? So the derivative is what? The derivative is equal to, okay, can you tell me what is the derivative of the first term? Yes, everyone, say.
2x.
2x. What is the derivative of the second term? 0. 2 over 5 is a constant. Do you have idea what is a constant? Constant means doesn't change. 2 over 5 is a number that doesn't change. But can you tell me what to do here? What is the answer? Can you do it in your head immediately?
1 over 5x.
What?
1 over 5x.
No, say one word. Yes, what is that?
No.
Yes.
No.
Now one word no, but you can just read it. What is the answer?
1 over 5.
Positive or negative?
Positive.
Positive. Because minus 1 goes down, multiplies by negative 1 over 5, it becomes positive 1 over 5. But then
X to the minus 2.
x to the power of minus 1, which is minus 2. So that is the derivative. And if I want to simplify this, I prefer to get rid of negative exponents. It doesn't matter, of course, but I would write it in this form. I prefer to write it in this form, but you can stop right here. Yes? So let me clear this. Okay, so let me give you another of this type. So number 6, let me call it g of x this time. But this method, even if you learn the quotient method in Math 4, if you get this question, if you give me this question, I know the quotient rule, but I will never use the quotient rule for this particular case. So if the denominator is one single term, even if you know the quotient rule, don't use it because it is lengthy. This is better way to do it. Okay, so let me just write one more here for you. Okay, this will take a little bit more time. Okay, let me give you one very simple one and then one that I pause the video and let you think, okay? So here I would say that what happens if I have minus 3 x to the power of 2 plus 5 x to the power of negative 3 and then plus 2x divided by 7 x to the power of minus 4. I want you to differentiate this function. Okay, again, what is the problem here? You see you have a fraction, but the good point again, if I ask you how many terms are involved in the numerator, 3 terms, but how many are involved in the denominator, just 1 term. So this is the trick you need to learn. So what we do, I just separately divide them. So it becomes minus 3x squared divided by 7x to the power of minus 4. And then I have 5x to the power of minus 3 divided by 7x to the power of minus 4. And then I have 2x divided by 7x to the power of minus 4. Here, the addition, I have addition. Here, I also have addition. So that's okay. And then what? Simplify it a little bit more. But you have to bring everything up, because that's the only option we have. So it is just minus 3 over 7. That's a constant. But can you tell me x to the 2 in the numerator, x to the negative 4 in the denominator? I want to write it x in the numerator. What is the exponent?
X to the 6.
6 or minus 6?
6. Positive.
Yeah, it is 6.
Yeah.
Why? Because you write this one minus this one,
yeah.
which becomes 6, yes? The rule is this, a to the power of m divided by a to the n. It is a, the one on top, minus the one on in the bottom. Okay, what happens for the next one? 5 over 7 is my coefficient. Okay, can you tell me x to which power? I want to write it in the numerator.
It is 1.
It is positive 1, yes? Minus 3, minus 4, which is 1. And then finally for the next one, 2 over 7, x to which power?
What does it say? 4?
4.
Yeah, then it's 4.
No, this is minus 4.
Yeah, minus 4, then it's 5.
5, yes? This is my function. Now if I can start differentiation. So tell me what is the answer. G prime of x is equal to... Okay, so this is negative sign. Don't get confused. So this is negative sign. So can you tell me what is the answer? What is my coefficient? Because 6 is supposed to go down, it will be multiplied by the coefficient behind that. What will be the answer? Minus 18.
18
Over 7. X to which power?
5.
5. Then I go to the next one. What is the answer?
5 over 7.
5 over 7 is the coefficient. The derivative of x is
1.
1. So that is just 5 over
7.
7. And finally the last one. What is the answer?
10 over 7.
10 over 7. This is the factor. And x to which power?
4.
4. And that is your derivative. Yes? Okay, I will give you one so that you can think about it and then we solve it together, okay? This will be a little bit lengthy, but be patient and calculate everything, okay? Patiently. So let me change the name of the function, for example, to u. U of x is, let me make a square third signs involved a little bit, yes? So I would write 5, x to the power of 2, the third root of x, minus 7, the second root of x, plus 5, divided by 7, x, the fifth root of x. Yes? So this is probably a little bit lengthy. It's not something that interesting. You have to do some algebra all the time. But I want you to improve your skills. So I will pause recording the video and wait for you to solve that. Actually, if you can solve this problem, you actually learn everything related to the notion of the derivative so far. Except for the definitions. Definitions are a different way of thinking about the problems. Okay, could you find the answer? Not yet?
I think.
So can you write, I write your answer and then we wait a little bit more. So what is your answer?
17 over 21. By 15th root
X,
of
X,
15th root of x.
X to the power? 2. So this is correct?
Yes, but 15th root of.
I don't understand. 15 square root?
Yes.
Where? Here?
Can I come around?
Yes, you can come and write.
Blev orientering.
Aha, 15th root. Yes. Then you can write it yourself.
Jag tror han kommer använda den där regeln som han skriver på. Som 1 over 2 square root of x. Men jag fattade inte vad som blev annars. Typ en tredjedel.
Jag fick rätt på det där.
Alltså jag
Den här metoden är fucking enklare.
15th root of this one, and this you can simplify by 2, yes? So let me, if this is correct, this should be 6 over 5. I don't know how many of you got this answer?
No.
No way. Okay.
Wait.
Okay. First, I want you to put it in GeoGebra to see what is the final answer. Let us see if we can do it here. I don't know, do you know how to put 5th root in GeoGebra? Expect, of course, exponential powers.
5th root. That's 1 over 5.
Yeah.
Something to the power of 1 over 5.
Ah, it's good. It's automatically taken. So you type it. I didn't know that. No, but this is not the light. It should go there.
It's hard to see.
No. This is not going there. I don't know what is.
Baba,
Is it
how do
only
you take the
projecting
derivative in a calculator? Baba,
Just let me think.
tar man det åt det?
This is very I should be able to change the display. I don't know who change these settings all the time.
If you have 2
Display
screens,
setting, yeah.
you can just drag GeoGebra over to the other screen.
No, let me see if I can.
You can also change to screen sharing mode.
Yeah, I want to find it because I don't use Windows that much.
I think if you go into display settings,
Yes, I am in display settings.
yeah, at the
Rearrange
top.
your display. Select the display below to change the setting for it.
Can I come around and
Yeah, you can come here and see.
Benji's?
Yeah, now extend this. Show. Duplicate displays.
There we go.
Keep changes.
So now your computer and the projector shows the same screen.
Yeah, that is So what you are doing here, Benjamin, now? And you are changing. The reputation at stake.
Yeah.
Don't worry, okay? Okay, let us check. Okay, so what I have to do, I have to move it a little bit here. And then I realize that I can switch the screen and record it in a better way.
No.
No, this doesn't show, but Alpha Wolfram, if you pay, will show you. Okay?
Pay the money.
So here, if you see, I don't know, I just typed it using the normal exponents as you see here. Yes? It's clear. So this is the way that I typed in, because I couldn't find anything on the keyboard of GeoGebra to this one. But then when I push enter, it becomes automatically the way that I want to have it. Yes?
Yes.
And then there's a derivative here, so I don't know if it will work or not here.
Let's see.
So let us see. So,
That's
I don't understand what is 0 then.
that's horrible.
Yeah, it is.
Negative 42 over 5
And the
times
point is that
infinity.
GeoGebra is this classic
very
5, I really don't like it that much. So you should be able to undo that, but then, so what is the meaning of that?
Yes, imagine.
What is going on?
So if you take the derivative, I don't know why, might be I should define it
Yes.
with f of x. So let me define it with f of x,
Try that.
yes, and then ask GeoGebra to differentiate it. It will give you this. But of course GeoGebra probably gives you without simplification. The point is that, do you know, I don't want to type it again. I want to ask GeoGebra to simplify this. So, okay, I can simplify the derivative. So f prime of x, yes?
Let's
Yeah.
see.
Hopefully this will work. No,
Wait.
this will That's very good answer.
Amazing.
How should I so do you know how should I simplify that expression?
Copy and paste in the simplified part.
So the copy paste in classic 6 is not as usual.
Yeah.
Copy input. Or I
Copy, it
want
says
to
copy but under
output.
text.
Pardon?
Under text it says copy.
Copy as
No? Yeah, copy that.
No, copy.
This is not copy.
Under.
Copy.
There.
Okay, copy. What did it
And
copy?
then you, I think it copies.
Then you do simplify brackets.
Simplify
Hopefully.
Yeah.
S and then Control V.
Yeah.
Wait.
Wait.
Is it that function now?
Yeah.
So I need to clean this f prime of x because it is
Yeah, I
not
think so.
good.
No, but yeah.
And then
No.
suddenly everything gone. You see, and Control Z doesn't work.
Control V.
I really hate
It's Control V.
GeoGebra Classic 6. Classic 5 is better actually. I don't know. It's very strange.
Can't you just go back ever?
Pardon?
Classic 5, don't you have it installed?
I have it installed. The only downside about Classic 5.
The answer is obviously 1.
Okay, here what I want to do, I want to write y equals to
Have you
brackets open. So what we are supposed to do,
No. Sure. Upgrade.
so it is 5.
He's trying
So
to
let
be
me
Christian.
open and close, and then open and close, and then go here. 5 x to the power of what? 2 multiplied by x to the power, I cannot write root here, I should write x to the power of what? 1 over 3. Yes, and then we go to minus 7. The square root of x, I can write it as x to the power of 1 over 2. And then I will go plus 5, and in the denominator I will have 7 times x times.
Well, the plus 5 becomes
I will
0.
go back. Let me do my job.
Doesn't it become 0?
Let me do my job.
Let me do my
Yes.
job.
Okay, so what I missed, just tell you now.
Don't forget step 5.
We cannot let you do your work.
Okay, okay.
But
Yeah.
plus 5, then
It's our job too.
Yes, okay.
Let's do his job.
Is that right? This is my function, but I want to ask differentiate it. Let us write diff. I hope that this is will understand us.
No.
Copy it first to be sure.
Copy everything.
No, you don't need to make sure.
No.
Let us see what it
What if it goes away?
It's all or nothing.
So it understands. This is your derivative. Because the reason that I see that Wolfram Alpha understands, because this understands, when I wrote DIF, it probably knows that I want to differentiate. Okay? And this symbol is the derivative, you see? So the derivative of this function, is that the function that we want to do? Yes, that's exactly the same function. So this would be the answer. Okay? But of course we cannot say this answer is wrong. I see that this is right probably. Because if you divide this by that, yes, you will get 17 over 21. And then that x to the power. But this one is, no, that is also right. There is, might be you divide. But that is the answer. Let me see if there is other alternative. Yes. This is another alternative. So this is really very clever and smart. So it is probably thinking that you need this version of solution. Yes. So the first version provided there was this one. That is quite correct. But we cannot immediately compare it with the Benjamin's solution here. But if you scroll down a little bit, you see that this is offering two other versions: alternate form, expanded form. So which one you prefer? We prefer this one. And now we can compare it with Benjamin's solution. Yes, 17 over 21, correct. X to the power of 2 over 15, correct. 7 over 10, this is problematic here. The last one is also a little bit problematic, yes? Because you have 6, you have negative sign, you have x to the power of negative 11 over 5, that's correct, but you don't have this one. And the middle term is probably wrong. Yes? So, I would say that 50% was correct. So, this Wolfram Alpha is a very important tool. By the way, you see here, it's written a step-by-step solution, but you have to pay. Yes? Okay, this is good to know about that. I want to go back to my window again and then try to do it together, okay? So let me pause that.
Human.
Are you recording?
Are you recording?
Yes.
Yes. Don't forget, please don't forget.
But unfortunately, so I will keep this answer. So what I do, let me tell you, what I do, I will simplify it in this way. Yeah, it is recorded. So here, this one, I don't know which one you prefer to do it.
The human way.
Yeah, I guess we have different humans, yes. We can do it faster or slower. But here, what I say, if you want to learn it pedagogical way, you can simplify these things first and then do the calculations. That's up to you. So this is x to the 2 and this is x. Oh, we are finished, yes, no?
5 past.
We have 4 minutes.
Yeah.
Oh, we have 4 minutes?
Yeah.
Okay, so we can calculate. X to the power of 2, x to the power of 1/3. Can you do it in your head? What is the answer? 5x to the power of what? 2 plus 1/3 in your head. What's the answer? 7 over 3. And the next one is 7x to the power of 1/2. The next one is 5. And this one is 7. Okay, can you do it in your head now?
No.
X times the 5th root. X times the 5th root.
4 over 5.
X to the power of 6 over 5. Yes? So it becomes 6 over 5. Now what I do, I actually start dividing them term by term. So, if you divide 5 over 7, okay, can you do this in your head?
No.
Okay, no. 7 over 3 minus 6 over 5. So it is 15. 5 multiplied by this is 35. This multiplied by that is 18. So 17 over 15. Yes? So this becomes x to the power of 17 over 15. The next one. 1/2 minus 6 over 5. 1/2 minus 6 over 5. What's the answer? 10. This becomes 5 minus 12. Minus 7. Yes? 5 minus 12 minus 7. So it becomes, and then 7 divided by 7 is 1. I have negative this one. And then finally this one divided by that one, I don't need to be worried at all because I just bring it up. It becomes x to the power of minus 6 over 5.
You have 1 minute.
Yes? Simplification process is finished, you have to multiply. You have to differentiate, sorry.
Yep.
So differentiation starts. 17 over 15 goes down. We can do it in our head, yes? You see, 5 over 7 multiplied by 17 over 5. These and these are simplified.
3.
So this becomes 3 times this is 21.
Yep.
And that is
Over
17.
Yeah, 17.
X to which power?
1
unit less.
Yeah. So
17 over 5 minus 1. 2 over 15.
Yeah.
The next one, this will go down. It becomes minus minus positive.
Positive 7.
1 unit less in your head.
Negative 3 over 10.
No. Negative 17 over 10.
Sorry.
Because minus 7 over 10 minus 1.
Right. Yeah.
Which is minus 17 over 10.
Yeah, I knew that, of course.
Yes. And then you make it negative in your head. This coefficient goes down. What is the answer? 1 second. The coefficient goes down. I put the negative one for
30
you.
divided by 35.
5 and 5 are gone. 6 over 7. Because 5 over 7 multiplied by 6 over 5. Do it human way.
No, I said
Yes,
no.
6
I
over
said
7.
30 divided by 35. That works.
I don't like it.
But it's
Because
correct.
this you need to learn to simplify, yes? And then x to power, okay, do it in your head. 2 seconds. 1, 2, finish.
Minus 11.
Yes, minus 11 over 5. And I hope that this is the answer. If this is not the answer, Wolf from Alpha made a mistake. Yes. Yes. So I think that was the answer, wasn't it?
Yes, it was.
Sure.
So you see, it is not that complicated. But if you are certain about this calculation, you are completely on the safe side regarding what we have done in the derivative. Okay? Thank you very much.
Baba, you showed us a rule.